like Lee space Han.
Yeah.
I also
Okay, we're going live in
Han.
5, 4, 3. And hello and welcome back to the brilliant Teams track from Dev Days Europe 2022. We have a talk now coming up by Mike Lehan, from the CTO from Students, and he's going to be talking us about learning by doing it wrong. It's really close to my heart, this type of talk. So, Mike, please, the floor is yours. Take it away.
Hello there. Sorry that you sort of saw me pop up in a weird way, having to sort of share the slides at the right time. The fun of remote presenting, and that's something I guess that we're all going to be learning from during this conference as to the various ways people do these things. But this talk is about learning from mistakes, and the best part of that is that if anything in this talk goes wrong, I can just claim that it's just all part of the plan. We're going to make some mistakes, and you're going to see them, and we can learn from them. So that's fantastic. But firstly, who am I? My name is Mike. I'm CTO at Students, as Stacey mentioned. And we're a prop tech startup in the UK. You can follow me on Twitter at M1KE. I'm also a northerner. That probably only means something if you know what different parts of the UK are like. And I'm a skydiver, and feel free to talk to me about that as well. So the normal way I would start this talk is with some audience participation. That doesn't really work so well when you're all in various parts of the world. But bear with me for a moment and join with me as I ask you a question. How many years have you been a developer? Put your hands up. No one's going to see. You don't look weird. 1 year? 2 years? 5 years? 10 years? 20? Oh, I see some of you putting your hands up for 20 years. Fantastic. I don't really. I'm in a room on my own. Sorry. But one thing you will know, whether you've been doing this for 1 year or 20, is that you will make mistakes. You're going to make mistakes. You've probably already made mistakes. And in fact, those people who have 20 years of experience have probably made a lot more mistakes than those of you who have 1 year experience. So, next time someone thinks that they're so much better than you, just ask them, well, how many more mistakes have you made than me? But actually, that's a really important thing. Many of the things that we've learned over those careers, over those 5, 10, 20-year careers, are because of the mistakes we made. And especially for people who are newer to development today, people who are just starting out, maybe even still training, maybe even just looking into this as a field that they might want to get involved in. Thinking about mistakes can make you feel a little bit worried, a little bit sick, a little bit like you don't want anyone to know the things you've done. But what I want to talk about today is some mistakes I've made. I'm going to share these openly and looking at the opportunities to make them a learning experience. And the thing is, when we think about mistakes, you're in very good company. I found this quote a few years back from the Washington Post comments. It says you truly become an adult when you finally realize that nobody knows what they're doing. And this was a comment by the wonderfully named anonymous user Fishy Bulb on the Washington Post in response to a fascinating and terrifying incident that happened on the island of Hawaii, where an erroneous missile alert sounded, telling residents that they had maybe minutes left to live before missiles hit the island. Now, this was a mistake. As far as we know, no missiles did hit Hawaii that day, but it took 38 minutes for anyone to issue a correction to that. And people did a lot of weird and strange things in that time. And all this came down to an IT system where 2 buttons that did very different things looked the same, and someone clicked the wrong one, and there wasn't a prompt or a check. And this was a system designed for a missile alert. On the level of priorities of what we do, missile alert probably comes below share photos of cats. But it still went wrong. It still had mistakes. And so this quote basically says, no one knows what they're doing. So we want to share mistakes. And if you feel that sometimes things are going wrong, well, just imagine how your PC feels. This is a GIF demonstrating the segfault. And now I'm going to lead from my career. I'm going to lead by example from my career and share some info. But maybe I am a little bit touchy about sharing these things with my name up here. So I'm going to reintroduce myself. Hello, I'm Dave, and you don't know me, but I made these mistakes. Mistake number 1, allowed a user to edit another user's profile. This is known as a 0-day. A 0-day is a security bug that's been in a system since the start, i.e. it was coded into the system was launched, released, and then an X amount of time later, in this case about 4 years, I think, a security bug is found. So it's called a 0-day because it was there from the beginning. It wasn't some new exploit. It wasn't some new way someone found to break your system. It was just coded wrong from the beginning, and it just took a long time for anyone to find out. And how do we do this, right? If you go on a website and you want to edit your profile, you would generally assume that you can edit your profile when you're logged in, and other people cannot edit your profile. That's a fairly common contract in building websites. Well, we have some code here. And in this code, we see some check. This is in PHP, but this code format roughly will apply to any dynamic language that you can care to think of. So, if you're not a fan of PHP, just ignore the $ and pretend it's JavaScript or Python. And in this case, we've said if the user that we're trying to edit is the logged in user, which we assume is an ID of some sort, then edit the user with the information from the HTTP post request. Otherwise, throw an exception saying, no, you can't do this. This looks like fairly good code. Some people, knowing that there's an issue with this code, have already spotted it. There's a single equal sign here. Now, the single equal sign in the majority of languages, and especially in this case in PHP, assigns something. It assigns whatever the value is on the right of the equals to the variable on the left of the equals. So this is actually saying not does user ID equal logged in user, it's saying make user ID equal logged in user. And we will then notice that in PHP, if you say this equals this, then it always comes out with true. So we now have a condition which, if you are logged in, is always true. And you see that and you're a little bit like, oh boy, this is bad, isn't it? Any user can now edit any other user's profile. This is not a good place to be. Now, as far as we could see, this site was relatively low traffic, and we don't think anyone had exploited it. So we wanted to fix the issue, right? A quick fix. We added an equal sign, right? Equal sign, the issue is now fixed. But is it fixed now? Right, the actual problem has gone away. But have we made this code better? Have we reduced the chance of someone deleting this equals again, or just copying this and missing out the equals, or trying to type it again and missing an equals? Could we avoid the chance of a mistake? Well, a simple thing we looked at after this in the team was just how code looks. Like when you look at code, so I don't mean running it through a scanner or something, just looking at it visually on your screen, how does your code look? Does it look like what it's doing? Does it look like something that you can understand? In this case, adding another equals, or even adding an extra equal sign, because in PHP you can have a double equals and a triple equals. They mean something slightly different as well, but let's just focus on the visual for now. And look, adding some spaces. Isn't the line at the bottom so much more obvious than the line at the top? Isn't it much easier to spot that those two do different things? And therefore, when you're looking at your code, sort of taking a view out of it, scanning down a big page of code, your eyes will spot that there's something wrong with this code. You don't even need a checker or a tester to spot it. The other way you can do this is flip the comparison. And again, most dynamic languages will work the same way here. If you say a variable equals some function, then that will assign the function. But if you say function call equals the variable, it will error because you can't assign a function call result to a variable. That's kind of odd. So in this case, PHP would fatal error. And fatal errors are great. A lot of people will be like, oh no, my server's crashing or something's going wrong. When something goes wrong, especially when it's around security, you would rather your site blow up than let the user do what they're not meant to do. And that's the same in most cases, because when it blows up, you hopefully have some sort of alerting or something that you'll see, or at the very least, your users will complain, hey, I can't edit my profile. A lot of users complaining they can't edit the profile is far better than one user ever editing another user's profile. The other way we can handle this is with improving the method structure. A common way is using what we call guards. So as you proceed through a method, you should check for all the things you don't want to happen before you allow the thing you want to happen. So in this case, we say, is the user not a logged in user? You can't make a mistake with a not comparison because you can't assign a not value of something. So you can say not is the user not equals to this, and then throw an exception, and then you do the thing at the end. The other cool thing about this structure is you can keep adding other conditions. Oh, is the user not activated yet? Is the user not allowed to because of some state their account's in? Is it a Wednesday and you don't like users editing their profile on Wednesdays? And then you, at the end of the process, you let the user edit their profile. And the same principle is actually used in TypeScript for anyone who's using TypeScript, and they're known as type guards. And you can do the same thing. Check all these things. And at the end, you know you've got the right type, so you're not going to blow up your system with a null pointer exception or an invalid type. Or what about tests? A lot of people are probably thinking, if you just tested this code, then it would have worked, right? If you had written tests. Well, we had written tests. But the thing is, when the tests were written, the thought was, can a user edit their profile? And they could. The tests were passing. The tests were green. Now we were lacking coverage because, as you might imagine, if you could never get that error, then you would never cover that line. But in this case, tests were checking for a happy path. And actually, you could even get the error line if the user wasn't logged in. So if you tested a not logged in user, the test would give 100% coverage. But you missed the fact that a logged in user could edit someone else's profile. So even 100% coverage wouldn't have saved us in this case. So checking code coverage and checking security. When you're testing, simply thinking about code coverage as a metric to hit 100% or a high number isn't enough if the application actually still isn't secure as a result of it. Security should be a #1 priority. And in this case, your application wasn't working. It's not working if it doesn't protect user security. So that is a lesson in a variety of things. And say, fortunately, I don't think anything went wrong with it, but we will, I guess, never know. Number 2, another security one here. This is a fun one. I let a database password get published to GitHub. This was fun, and this happens all the time. So I'm not even that embarrassed about this one. There are GitHub credential breaches. GitHub now have systems to scan for credentials because of how many people decide to leak their credentials on GitHub. But how did it happen? Just trusting that GitHub's going to fix it for me isn't a solution here. So we hired an intern, and this was kind of cool for a company. The company was growing, and at this company, we decided to bring on an intern. We thought, training people is great, and to this day, I still love training people. This was a long time ago, and I've learned a lot about training people since then. And then we gave them some test scripts to go and do something with our data, right? So it wasn't our main code base, just some test scripts. Go and do this. We want to see if you can get some insights from our data for us. And then on Saturday, the phone rings and we get told, oh, they were enjoying their work so much, they worked over the weekend, and they decided they wanted to show some of their friends from their training course. And so they put it on GitHub. They put their test code they'd written on GitHub. And so then I go on to their GitHub repository and, oh dear. Not only had they published all the code, they had published our database password and the URL of the database server as well. And this was a password with full access to the database. Well, what went wrong? This was a new staff member, so someone who hadn't been trained. And not only a new staff member, it was an intern. It was the first time we'd taken on an intern, so we didn't really have a process for bringing interns on board. We were storing credentials in PHP files. Now the view was, oh, we're making this little script for someone. They're probably not going to leak it, but that was still a bit of a naive error. We should have stored the credentials somewhere safe and given this person proper training in how to manage that credential, and that's a very important lesson as well. And ultimately, our main code base had also at the time been checking files into version control with a password in them. And so we weren't leading by example. We were setting a wrong example. Even if this new developer had looked to sort of see, oh, should I do this? Oh, I'll look elsewhere for an example. Oh, yeah, they're doing it over there. This is fine. People don't know. They don't understand these things. So it's essential to set examples for a team. But there are also technical controls. We can store secrets safely. We can use environment variables, we can use config files, and we could use API-based secrets managers to store things for us. Environment variables, you may be familiar with these from any work you've done in a CLI, a terminal environment. Environment variables just look very simple like this. Here's your DB user, and you're giving a DB user root, and you're passing it into, in this case, a PHP script. But again, this would work in most languages. And we can echo out the word root. And there we go. We've got our environment variable, and our code doesn't have that secret stored in it anymore. The code simply references a variable. And we can also use .env file. So .env file, we can store the root username, the root password, all the credentials we need to, and pass that in. The cool thing about envvars as well is they are generally universal. They can be used in a CLI. They can be used in a Docker environment. They can be used in most coding languages. So you're kind of portable between even different people's setups and different people's ways of working. You can store them in a command line, and a lot of web server configs, Apache can load environment variables for you, pass them into your scripts. So again, your scripts don't know it. As long as your server's configured securely, your server might know the secret, but your code doesn't know the secret if it's on a developer's machine. And we can store safe versions. So we might have a dev environment variable. So it's common to use .env.dev, .env.staging, .env.local. And if you've got a .env.local, you might actually check that one into version control, because maybe that just contains, the database password on your local environment is blank because you're just developing and testing. So you can check that one in, but you don't check in .env.prod because that's probably much more important. You maintain that somewhere else outside of your repository. And so devs can even combine these files. So a dev could have a .local and a .local.me, so that the .local.me can override things. But again, that doesn't get injected into version control every single time they make a change. Problems of envars are that because they are quite widely used, lots of systems can use them, and you might forget which systems have access to your environment. So you start running a piece of code, and that code calls something else in a shell. That shell will have access generally to the environment variables that the code is running with. And in this case, especially if you were allowing user input into a shell command, you could start to get some security holes there. There's also a lack of clarity available. If you're just declaring everything as an environment variable, you have to be careful in your code to make sure it's very clear which things are coming from the environment. Simply just dropping process.end if you're in a JavaScript environment, or sys if you're in a Python environment, into random bits of code to pull things out of the environment isn't very helpful for someone who wants to run that code, knowing what they need in their environment before they start. So you have to think about your code structure around that. But if you are using an envar loader, you could just load a config file written in the language you're using. As long as you don't need to share between languages, then it's probably fine. There's also API-based secret storage. So in this case, I'm just giving 2 examples. There's plenty more out there. HashiCorp's Vault is a service you can set up yourself. You can run on your own systems, and that can store secrets for you. The only con of Vault is that you have to now manage your secrets manager. Your secrets manager becomes a single point of failure. If your secrets manager goes down, none of your systems can access your database or any of your other credentials they're using, and that's probably going to be an issue for you. There's also AWS Secrets Manager. I cite this one purely because I'm an AWS user. The other cloud platforms will have their own sort of parameter or secret management. But AWS Secrets Manager is a great service, API-based. You can define really fine-grained access controls for individual secrets. So this server can access these secrets, this server can access these ones. You can have a combination. And the only problem with Secrets Manager is that if you're storing loads of secrets in it, it does get quite expensive. But what you can do to get around that is you store a single secret, which is like a JSON document of all your other secrets. You lose some of the fine-grained access control, but you save some money, and you could cache that on your server for a short amount of time, as long as you don't need to rotate your secrets very regularly. Okay, problem number 3. We mail bombed a whole mailing list. This was a fun one. Was building a system one time to essentially do like a mail out, sort of MailChimp style. I can't remember why the business at the time didn't use MailChimp, but maybe they didn't like it. But I was tasked as a developer, and I think I was working on my own at this point as well. So I can't even blame this on someone else like an intern. I was tasked with building this mailing system. We were going to go through a database we had of users, and we were going to send them all an email. So built the system, did a bit of testing, sent a couple of emails to myself, seemed to work. So we run it for the first time, and it seems to be going out normally. And then a message pops up. Yeah, they say that they just received the same email 1,000 times, but with more users copied in. And you see a message like that, and you're sort of pressing the stop button. Like, oh dear, it's all gone wrong again. What's happened? Well, here's the code. Again, this is PHP. I got a Trojan to write these in different languages, but I was writing this in PHP at the time, so it makes more sense. And here's some code. We look through some messages. We set some subject, set some HTML. We add a recipient, and we send it. Cool. That's how you send emails, right? Subject, body, who are you sending it to? Send. What's wrong with this? Well, we blank out a few of the lines. We'll see the culprits. We have a method here called add recipient. Add recipient. That's what I need to do to send an email, right? I add the person who's being sent to. What we do see is that we're not adding our recipient to our message. We're adding it to our mailer service. So the service has all these items set on it. And so add recipient is a sort of prefix format. Add something. Add something generally adds something to a list. This is often a sort of convention we use within our code. So each time we looped over this list of messages, we added a new recipient to the emailer, but we didn't remove the existing ones. So then each time it went out to one extra person, leaving the person at the top of the list with a lot of emails in their inbox and very unhappy. And this quote is here. There are only 2 hard problems in computer science, cache invalidation and naming things. This is a little bit related to cache invalidation, but very related to naming things. The add recipient function and the send function there were wholly inaccurate in terms of the implications of what doing them would mean. There was nothing in the code to suggest that looping over this thing and doing add recipient multiple times would be a problem. So the first thing we did was we made a new function called safe send. I say we, I made a new function called safe send. I'm used to just attributing everything to we because I don't like blaming people, but in this case it was me. Safe send, so we send and we clear recipients. So you now make a rule in your code base, you put a little comment on the send method saying, don't use this, don't do this again. Use the safe send method. And the next thing we can do is to say, actually, let's have a separate function that sends a message by setting that message each time. So we set the to on the message, and then we have the emailer send the message. That's a more logical way of writing our code. But then the question comes, well, we've now just removed a feature of our system, because previously our system could send messages to multiple people if we wanted it to. We've just removed that feature with this. Have we lost a feature? Have we lost something we wanted to do? Well, you can just add that back. Add another method that's very clear, send to multiple. So if I want to send a message to one person, I have to type the send thing. I can't make a mistake with that. If I want to send to multiple and I write send, oh no, I've only sent to one person. That's not the biggest error in the world. The error the other way around, I wanted to send to one person, I've sent to 1,000, is a far bigger error. The best code is obvious. The best code is going to tell you what it's doing and to give you an idea about what you're getting into before you have run the code, just by reading it. On to our next problem. We're about halfway through the list here. They do get more destructive as we go as well. Hiding errors where nobody could find them. If a log line arrives in a file and nobody reads it, does it still sound like screaming? The answer is yes. Your service isn't working. I don't know how you know your service isn't working. Maybe you're getting messages from your customer support team. Maybe you're getting messages from other developers. Maybe people are bad-mouthing you on Twitter. That's one of the worst ways, I think, to find out your service isn't working, isn't it? Whatever happens, something's wrong. You know there's something wrong, so you go and check the logs. And you go into your app log errors directory, very well named, and you check how many error lines there are. And oh my goodness, there's 2 million of them. 2 million error lines. How long have they been there? How long has this been happening? What is wrong? Will I still have my job tomorrow? And what happened here? Well, we have a task, important task. It's a great function name. Do my important task. And do the thing here emits an exception. Now, in most languages, if you throw an exception, you will have your exception bubble all the way to the top of your code. And if it doesn't get caught anywhere, your code will blow up. And then you'll still get an error somewhere. But actually, now your users can't access your site. So you get around it fairly easily. You put a try and catch around it. This is one of the things that people who are programming in Go will be very aware is quite different in Go. In Go, you're always made to specifically handle error cases from each function return, rather than being able to kind of pad them down like this, although there are still ways around it in Go. But Go is quite good for that it makes you think about the error cases rather than just wrapping try-catch around everything and you have no idea where your errors are being handled. But for most languages that aren't Go, we have to have this format, try and catch. So we catch the exception and we log it. Great, we've sorted it. No longer is our IDE telling us that we've got an uncaught exception here. Our code checking tools are all working. We're logging the exception. Great. But who's checking that log? Who's actually going and verifying if those logs are filling up? What's in them? Are we logging anything? Is the log just outputting array, which can happen in a lot of languages. If you accidentally log an object or a structure into a string, you just output array and you have a log line with the word array 2 million times. Isn't going to be very helpful when you're trying to debug something. And this all comes down to one thing. I'll deal with this later. And for anyone familiar with Arrested Development, you can hear the narrator in the background saying, he didn't deal with it later. And now he ends up with a lot of logs. And you have so many logs, and if you're using Docker, you end up with this situation. All your logs falling off the sinking ship. Well, we need a better way to handle this, don't we? So one thing is logging everything to a single source. It's quite common when you're developing a system to take a log file and say, okay, this is my user controller. So I'm going to log errors to users.log. And then later on, I'm working with my payment controller. Okay, payments.log. And eventually we come up with this kind of weird internal convention of logging stuff to different folders and different files. And maybe we split them by date or something else as they get bigger. And we end up with this menagerie of log files, which can be really complicated to do anything with. And one thing we need to do is make sure all logs go to a single source. So in PHP, there's a service called monolog that clues in the name, monolog. You have one log. Everything goes into one log. And in various other environments, there are logging tools that will take your logs and send them somewhere. You need to consider your log levels. Is this a debug log or an error log? Because error logs probably need to be somewhere prominent, and debug logs might only be needed if there's an error. is that going to be helpful for you to describe every single thing in your system as a debug? User failed to pay, debug. That's probably a warning at the very least, isn't it? And we want to link them with something like a transaction ID. So if a user is coming from your front end and then into your back end and then continuing back to your front end, do we have a way of linking those different activities together? If we have a payment service, so we use microservices, a payment service, a user service, can we track the progress of a user through that system so we know where they went wrong? And there are log management services. I'm hoping when I started giving this talk, probably a lot less people were using these. I think the usage of log management services has been going steadily up, which is great. But I imagine there's still some people who aren't using one, and consider this your push today to start using one. It's a relatively easy step to make, and very quickly it will pay dividends. So you've got the ELK stack, Elasticsearch, Logstash, and Kibana, whether you're using Elastic's own stack or one of the sort of derivatives, like OpenSearch. You've got AWS CloudWatch, and again, this is my knowledge of AWS coming through, but GCP, Azure have their own logging tools that you can send logs to from various services. And Datadog, I particularly do recommend Datadog's logging tool. It's incredibly easy to set up, and I've used it extensively for, again, logs from a range of services, and throwing all the different service logs into one big pool initially sounds a bit overwhelming, and how am I going to manage this? But eventually you realize it's the only way to do it, because then you can easily cut across different types of logs, match different parameters. Oh, this IP and this IP are the same. Okay, it's the same user doing the same thing maybe. So having those services set up is great. But another thing to consider is just why we're doing any of this to start with. Why are we recording logs? I generally split monitoring systems into two aspects: visibility and awareness. And these are just words, and especially if people here are non-native English speakers, it might be uncertain what these directly translate to and how those are different, but I'll try and explain it a little bit. I define visibility as giving insights into how a service is operating. Visibility means you can see something. So they're detailed. Generally, visibility also requires knowledge of something. I can be staring into a car engine, and unless I have knowledge of how the car engine works, it means nothing to me to be looking at that car engine. So in this case, they require knowledge of the tool to understand. There's no point me staring at a car engine. I don't know how to fix a car. I need someone who knows how to do it. And logs are also generally verbose, so we get a lot of information. So if someone was trying to fix my car, they don't just have a brief scan and start pulling wires out and start throwing oil around. They have a look at all the different bits and how they're interacting and how they're working before they make a decision as to what they start working on. The other side is awareness. And awareness is getting a general gist that something is wrong. So whilst I can't fix my car, I can be aware my car's not driving correctly. It's stuttering when I pull away at the traffic lights. It's taking longer to start up when I press ignition. Various things will tell me that, even if I'm not an expert in cars. The fact that I drive a car means I know enough to see that. And awareness is something we can really focus on in our applications to gain that. I have a great story about a time we published a dashboard in one of my businesses, published a dashboard and put it on the wall on a TV, Raspberry Pi TV, etc. And put some graphs on it to show response time from the database, I think it was. And I just put a red line on the graph that said, over this is bad. And then one time, one of the customer support staff was just walking past on the way to get a coffee and said, hey, the blue line is over the red line that says it's bad. And suddenly the tech team were aware of an incident. We were aware of it by the virtue of someone spotting it. Now, obviously, there's maybe better ways we could have been aware, but it's kind of cool that someone who had no idea of that system, because we had made something very clear, they had the awareness that something was wrong, and then they knew to flag it up to us. One thing that awareness and things like metrics don't give you is that you don't know how to fix it. So again, I know my car's misbehaving, but I've got no idea why. That's where I need the logs. So metrics and notifications are ways you can gain awareness. Metrics are generally a count or averages or sums from a service. And again, things like Datadog, there are other sort of agent services. You can run them on hosts. You could send metrics from your system. Send a metric every time a user logs in. Send a metric every time someone resets their password. If you see more password resets than logins on a day, that's probably an indicator there's a problem, even if you don't know what the problem is. And you can boost awareness from your metrics using dashboards or alarms. Dashboards are great for just passive sort of awareness. Alarms are great for telling you something's wrong right now. You've got to be careful with alarms. If you set an alarm on every single metric on a certain threshold, your team will get really tired of alarms going off all the time. And consider notifications. So this says PHP errors because I previously gave this at a PHP conference. But pipe errors from your system into Slack. This was a tip I got years ago from someone who took over projects as a business. So they took over failing projects and made them good again. And one thing they did was they piped errors into Slack, and that's really, really annoying for your team. And so your team go and fix them, which is, kind of cool. Obviously, your team might also mute the chat if it's too busy. So follow some sensible best practices about that. If you're getting 1,000 errors a minute, probably don't put it into Slack. But if there are errors coming through and they're going into Slack, your team are going to fix them far faster than if they're getting emails or if they're coming through some third-party service that they're not connected to. Your team are probably on Slack or Discord or whatever else you use, Teams. Put your messages in front of your team so they're aware and they are driven to fix it. And email people on critical transactions. Did someone start the checkout flow and not finish it? Maybe someone should get an email about that. Right? Is that an unusual thing? Have your application tell you it's working. And you can turn logs into metrics. So things like Datadog and CloudWatch, AWS CloudWatch, you can put filters on your logs to say, hey, make a metric from this filter. And so you can use the two in tandem. Number 5, we'll get into the big one. Deploy half a feature branch in production. This was a really weird one. This is a problem I think is probably shrinking in use cases. And eventually I'm going to be giving this talk and people are going to be going, how do you even manage to do that? But it's a good story. Better tooling can save your career. And this is something that I think some people probably are still doing and still risking. So again, if this is you, feel free to use this as a push to yourself or to your boss to finally go and fix this issue, because it is an issue. The untraceable bug, these are the worst, aren't they? Users are experiencing weird errors. Pages were loading data that shouldn't have even been there. And then you were saving some data and it changed to other data. You're sitting there thinking, maybe the laws of physics have just changed. Okay, that's the only explanation for this. The laws of physics have changed and my CPU is just doing weird stuff, right? It's gone into the quantum realm and it's making stuff up on the fly. That's the only explanation for this, because my code's right, isn't it? And it works on my machine. This was the most frustrating thing about this bug. It worked. We pulled a production database down onto a dev machine. We ran it and it all worked fine. But when we logged in as users and went on a live system, the bug was there. How? The same code, the same data. How is it working in one context and not the other? Well, let's look at our deployment process. At this time, our deployment process was quite complicated. We checked out the branch. So check out the branch you want to deploy, usually like master or sometimes like a feature branch. And then you run a set of commands. You got to run this one, then this one. Then if this one does this, you run this thing. There was like a run book to do it. And then we deployed at this point with an FTP tool. So copy all your files, drag them across, and drop them on the server. Yeah, you can probably already see some issues. So in this specific instance, I checked out the wrong branch. And to make matters worse, because we were reliant on literally copying and pasting files, I had only checked out copied and pasted maybe half the files. Now, if I'd pasted all the files across, we could have said, oh, this is well done, users. You found an unexpected feature. It's a new feature. We've just released it today. I'll gift to you. Could have made it work. But because we deployed half the code, the system was basically talking to a different version of itself. Different files from different branches were talking to each other and producing weird outputs. I'm surprised the system didn't just completely crash, but there we go. Bad luck on our part. So you need to know your deploys. We focus so much on lots of parts of the software lifecycle: requirements gathering, code writing, sprints, TDD, testing, quality assurance. And then deploys, we just sort of go, I don't know, there's a rocket and there's a cloud and it gets to the cloud somehow, maybe in the rocket, maybe somewhere else with the rocket. And we sort of push it to one side. Our deploys are the last thing. I'll just do those. So a few lessons from this. Your deployment tool should be version control aware. This was a very easy fix at this time. Make sure you can't deploy anything if you're not on the right branch. That seems fairly obvious. And the next thing is you want deployment to be one action. Make it so that you don't have to jump through all these hoops to deploy something. Press a button. Even get an actual button and wire it onto a desk and build an Internet of Things connected system so that button deploys your site. Probably don't do that, but you can build a system which is super easy to use, and then your deployments will look like this. Do you remember the feeling you had when you saw those rockets touch down at the same time? We want our deployments to be like that. Every time it goes up, it's just like, oh, it's perfect. It's wonderful. And there's plenty of tools to do this. So you've got JavaScript-based tools, things like Grunt and Gulp. You have Jenkins, the classic open source CI, more modern CI tools like Circle, and even old school XML-based tools like Apache Ant. They all still do the same thing. They deploy your code for you. They build a system for you. Even just Bash scripts is better than having to have someone jump through a bunch of hoops and do a lot of manual actions to deploy something. And a few deployment formats that you might consider using. Atomic deployments. So you can deploy to like a timestamp file, and then your web servers or whatever serving switch at the same time. So you say, okay, move over to the new version now. Or you can do, of the challenge of that, is that your application might expect certain things to be true. So if you have a version of your JavaScript going up for your front end and your back end, and there's a bit of a time delay as those go up, or the synchronization is not quite right, you might serve the wrong code. So you have to be a bit careful with that. The more popular modern method is blue-green deployments. If you're on auto-scaling tools, so AWS is EC2 or any VPS hosting, and definitely if you're on a Dockerized environment, this is a great way of doing your deployments. You bring up an entirely new set of servers with your new version on, and then you move your traffic via something like a load balancer over to your new setup from your old one. And then you monitor your errors. If you don't get a sudden flood of errors into your error logs, you bring down your old service. If you do get a sudden flood of errors, you just repoint your load balancer onto the old service and bring the new one down, and then try and figure out what was wrong and fix it. The only caution with this one is if your new service makes changes to your database, your old version still has to be compatible with those changes. So if you are doing database things like especially table renames, deletions, I would definitely recommend against ever doing that on a production service. You will have to think about that if you're ever flipping back to an older version of a system. Here's the biggie. I deleted 100,000 user uploaded photos one time. This is a fun one, and this actually dovetails off the previous point of deployment. So we realized FTP was a bad thing, and so we sort of decided to slowly increment towards a better tool. So firstly, we built a CLI tool to do deployments, and using rsync. Rsync is a great tool for synchronizing files between servers. It will do a diff of your files on both sides, so you're not sending loads of data every time that you don't need to. And it's more secure, runs via SSH. And rsync has a there we go. And we decided then to, after building rsync, we decided, okay, we now need to put this in a JavaScript tool. So we're using Gulp at the time. So build the same thing into JavaScript. So we found a library on npm, because everything's on npm, isn't it? To do rsync for us. So we have the same process. You can see we've got our source, our destination. We're using SSH. Yes, we are. Ignore that last item, sync dest. We'll come back to that. And so we decided we're going to bring our deployment process in, and we deployed. There we go, our perfect, beautiful landing of our 2 rockets. And then we get a message to say, oh, the site's not loading photos anymore. And we think, oh, that's odd. We haven't modified the photo loading tool as part of this deployment. We're in some other part of the site. And we take a look in the directory where the photos are, and there are no longer any photos. And then we take a look in the directory where all the other user uploaded content is, and that's not there either. And all our logs are gone. And suddenly we realize our deployment process is a little bit more like this. Wait for it. Wait for it. Kaboom. Everything was gone. What went wrong? Well, rsync has this feature called --delete all. Now, --delete all is a really well-named feature. We talked about naming earlier. --delete all does what it says on the tin. If you run rsync with --delete all, it will delete everything on the remote server that isn't local. For example, user uploaded content, which isn't on your local machine when you're deploying. But it's called --delete all. It is hard to ever typo that. I have never accidentally typed --delete all without intending to. So this is a fairly safe thing to put in the rsync platform. Someone has to really want to run --delete all. Let's look at the version that we used on npm. So npm wrapper around rsync, and we see this line sync dest. Sync dest, that's a strange sync dest. What does sync dest mean? Well, this is the same example of that code now. Oh dear. Sync dest was a badly named copy of the flag delete all. So whenever whoever had written this rsync platform had decided to copy the options from rsync, they decided delete all sounds a bit bad, doesn't it? It sounds a bit scary. Let's rename it something much more palatable, such as sync dest. And let's put that in our example on our README so that people definitely use it and have it turned on as true and delete all their files. The change there that you see where we've renamed it to delete all was made by me via a pull request. And I think it was one of the most polite pull requests I've ever written, considering how I was feeling at the time. But you do have the obvious question, right? We've got backups. And then we're left there looking around for our backups like, oh dear. No, we didn't have backups. And we didn't have backups because we hadn't ever assumed someone would wipe the entire contents of a hard drive. We were backing up our database. We had a great backup tool on our database. It was nightly. It was doing nightly backups, and it was a really good system. We had checks in place, and it was just wonderful. The database was backed up, great. But we hadn't thought of backing up our files, and the reason was just basically, I'm not really sure how to do that. There's a lot of them, aren't there? Let's do it later. And yeah, that's not really a good enough reason, is it? You won't know you'll need your backups until you need them. This is the problem with something like backups. It can seem like a lot of time and effort to do something that ideally you will never need. Couldn't that time go into building new features for our customers? Well, it could, until one day someone comes along and hoses an entire directory of content and you lose all this stuff. You need your backups. You need to check your backup process is running. It's not just good enough to write it. You need to check it's running, and you need to check it's backing up the right stuff. Thinking your backups are great and then going into your backup folder and finding 10 million 0-byte files would be equally upsetting, and maybe even more annoying because you've invested the time in building backups and they don't work. So keep checking this forever, all the time. I can't stress it enough. If you are right now sitting there wondering about your backups, and with no disrespect to whoever's talking next, go away and check them. Go and have a look. Or ping someone on your team who's not at the conference and tell them to check. Because if you don't know where your backups are right now, then to some extent you don't have backups. And it's worth bearing that in mind as well. In conclusion, this isn't a canonical list of all my mistakes. I only had 45 minutes to talk to you. Normally, I would invite you to buy me a drink afterwards and we can chat about it, but we're all remote, so you can't. Maybe you'll see me at a conference in future or some other event and you can do that then. But one thing I really want to encourage you is don't just let it end with this talk. Whether or not you thought my mistakes were helpful and you've learned something, or whether or not you're thinking I've made bigger ones, or whether or not you think that I'm just stupid and you're better, go away and think about the mistakes you've made. Think about the learning you've had from them, and then go and share them with someone. Talk to someone who maybe is worried about making their own mistakes. Talk to a junior on your team, someone who's just learning, who is terrified of making a mistake, and that itself is limiting their ability to do anything. And show them that mistakes happen. Show them how we can deal with them, how we deal with them as a team, how we have procedures and practices in place to deal with them. And also how actually, if you share the mistakes you've made, the next person won't make them. We're often worried, especially online, our reputation travels quickly. Am I going to share a load of mistakes on a conference talk, and then the next time someone's looking to hire me, they look at this talk and go, well, this guy sucks? Well, I don't think so. A good hiring manager should look and go, oh, wow, you've made all these mistakes. That's great. You will bring a lot of learning into our team. You will bring so many things to our team from these mistakes you've made that you've learned from. And if we don't share those things, if we keep them under wraps, if we keep them quiet, especially if you've made a mistake recently and you're trying to hope nobody in your team knows about it, try and reverse that. Share what's happened. Talk openly about it. And create a culture where people can share mistakes. Don't create a culture of blame and where people are pointed at for their failures. Create a culture where people are encouraged to open up about those things. And that's all why I've been talking about this. Getting in at the deep end of this software development process. If everyone sort of is very tentative and everyone is not willing to make mistakes, we're never going to build anything big. We have a world where small teams, small founders create huge companies worth billions. And a lot of them took those risks, and we might think some of them were good or bad risks, but we need to take those things and we need to learn, and we need to build a culture and create spaces to share and to encourage that learning. So if you're going to take anything away from this, if it's not the technical stuff that you might take away, it's that please share, please join with people in encouraging learning, encouraging owning and learning from our mistakes. And with that, thank you very much for watching. Hopefully some people are out there watching. Once again, I'm stood in a room on my own, so it's a bit hard to know. Please do tell me you have been watching by tweeting me at M1KE. or dropping things in the chat, or however else you want to get in touch with me. It would be wonderful to hear from you. If you've got any questions, I don't know if I have any time for them, but I think Stacey will take over now as well.
Yeah, thank you for that. I have written down so many comments of memories that you've jogged from my career of all of the things that I've done wrong whilst I've been learning and working. Unfortunately, we are literally, the timer's just gone down to 0 for the session, so we don't have any time for questions. But I do just want to really emphasize what you said at the end there. If you are in a position where you can be an example to others, if you are someone who is higher up than the junior developers, shout your mistakes. Let people know that it's okay to make mistakes, because like you say, it's the only way that people are going to know it's possible and safe. And it's the only way that people are going to learn.
Absolutely.
Right. I would like to thank you very much for your talk today. It was really fantastic. I got a huge amount out of it. I hate the fact that we don't have time to talk, but we don't want to take the time from the next speaker. So please, if you've got questions, contact Mike on Twitter, and I will see you in about 5 minutes for the next session on the Brilliant Teams Track. Thank you again, Mike, and bye-bye, everybody.
Brilliant. Thank you very much. Goodbye.
And we're